Maybe you were good yesterday, but you are not off to a good start today. We're very unfocused. Well, I am going to give out the extra points, but I'm not evil. Justice, your group can have an extra point. Paige, your group can have an extra point. Daniel, your group can have an extra point. AJ, your group can take a point away.
Yeah, take one away.
That's correct. Okay, let's go ahead and get started. The sub wrote me a note that everyone, I was going to check for page 2 and 3, so the sub wrote me a note and said that everyone except one person had page 2 and 3 done. So, I heard that. Should I check to confirm?
No.
I mean, I did it, so
Okay, I'm gonna pretend that you for real have it done, because she wrote me a note that one person needs to get it done and show me that they have it done in order to get their points. Otherwise, everyone else is getting their point for page 2 and 3.
it's right here. I did.
No, I'm not. Look. I actually did all of them.
Okay, so I'm assuming you've done page 2 and 3. Actually, get out page 3. Let's go to the last full problems. I want to talk about those. Do you have any questions besides 19 and 20? We're pretending you did finish it, because you should have. Do you have any questions besides 19 or 20? Last period had a question about number 18. Y'all don't have a question about 18? Let's rephrase. You ought to have a question about number 18. Okay. Are there any other questions from the worksheet you were supposed to complete yesterday that you have? Okay, even though I'm assuming, because the sub did write it out and say y'all had this done, even though I'm assuming you have this done, I'm still going to know whether or not you understand because of that checkpoint, which we're not going to get to finish today. We're going to push that off till tomorrow. I got a lot to say today about multiplying. I already can tell from first period that's going to take the rest of the class just to do the notes. But tomorrow we'll worry about did you pass the checkpoint and getting that checkpoint passed. Speaking of tomorrow, make sure you bring your workbook tomorrow. We are working a page from the workbook in addition to passing our checkpoint. So you've got to have your workbook with you tomorrow. Okay. The reason Paige and Daniel got points is because Paige caught a typo I made, which I appreciate, because I am not perfect, and I wish someone had been there to check my math at that time. But the principle of the matter is the same, so it's fine. And then Daniel gets a point. He also caught the typo, but because he made me aware of the fact that you were having to watch on your phones. Anytime I'm not here, because again, that's going to be a potential thing for us from here on out. Anytime I'm not here, I leave it all the way set up. Somehow my charger fell behind it. You are more than welcome to come and look around or whatever. Or do what Daniel did. And I know most people say, please don't bother me when I'm off, but please do, because I want to know y'all are being productive. So if something's going wrong, or you're having to watch on your phones, or something's not just she's ugly, but like something genuinely is wrong and you need me, you can message me, because once he posted that comment, as soon as I saw it, I don't think it got fixed second period, but at least third period got to watch it from the screen, because he let me know, so I texted Miss Asbury, and Miss Asbury came and fixed it. But y'all are more than welcome to like handle your own thing. It tells you on I have a note on my laptop that tells you the passwords in my drawer, like whatever, you can make it go. You are that good. But the good news is that Google Classroom posted at the same time, which is good. It's just, I get like how that stinks, because now you're wasting your battery and your data or whatever, so I get that. That stinks. So I hope that doesn't happen again, but if it does, the charger is here, I promise. I left it. Okay. That's why they got extra points. Justice got extra points because he came and finished or continued to work on his test during 0 period. He was the only one brave enough to do 0 period but sub, I guess. So that's why he gets an extra point. 18. X and Y are easy. The hard value is Z. Does anyone know what Z is supposed to be on number 18? It is 0. And you can have a point for that. So 8Z equals 4Z. Let's say you subtracted 4z from both sides, you would have 4z equals 0. If you divide by 4, you'd end up with z equals 0. But regardless, just in my head, the only number I could plug in to make 8 equal to 4 is 0. Because if you plug in like a half, well, yeah, that turns 8 into 4, but that turns 4 into 2. So the only thing that was going to make this work is 0. So that was one question you should have had. 19 and 20, I said you could do by substitution. Did anyone do that and get an answer? Yes, dear. Either of you. And what did you get for 20? You get a point for that.
20 is x equals 12 and y equals 3.
Get another point for that. Okay, so we like matrices because they make life easier, but sadly 19 and 20 doesn't make our life easier. So the top entry is still equal to the top entry. The bottom is still equal to the other bottom entry. But what stinks is both these equations have x's and y's. So, oh no, we're stuck. No, we're not stuck. We just took a test on substitution. So everywhere in the second equation I see an x, I'm going to plug in 4y. So instead of it being 3y equals x minus 3, I'm going to have 3y equals 4y minus 3. If I subtract by 4y, I'll have negative y equals negative 3, so y equals 3. And just like with substitution normally, once you get y, it's easy to get x. You can plug it back into either equation. So I'm going to plug it in the top one just because it's closest to me. X equals 4y. We just found out y was 3. So x equals 12. So 12 and 3. Okay, 19 is the same thing. 2x equals 6y for our top equation. Y plus 2 equals x for our bottom equation. I'm going to decide to solve that bottom. No, I don't have to. It's already set up x equals this. So everywhere in the top I see x, I'm going to put y plus 2. So 2y plus 2 equals 6y. 2y plus 4 equals 6y. 4 equals 4y. So y equals 1. And then when I plug that back in to either equation, I'm going to do the second way just because it looks easier. It used to be y plus 2 equals x. We just found out y is 1, so 1 plus 2 equals x, so 3 equals x. So they're not difficult, it's just requiring a combo of what we just tested on and what we're learning about now. Are there any questions about 19 or 20? Okay, then let's go ahead and get these math workshops out of the way. What am I supposed to do on number 1? Ellie, get a point. What is the DCF I can pull out on number 1? It's 12 xy, and what are you left with? 2, 4, and 5 get a point. Six goes into both, but 12 is a bigger that goes into both. So they are correct. Number 2, how many terms are there? What are you supposed to do? 1 and 5. I didn't hear 2. 2 say it? 2. Okay, so if we do grouping, what do we pull out of that first group?
Negative x squared.
You are always being different from me. You keep rolling. You're going to be fine. We're just going to have different signs again, but it's still fine. I pulled out just positive x squared, and I was left with x minus 5. What did you pull out on the next one then? A negative 3?
Yeah.
Okay, I'm going to pull out a positive 3. That's our signs are going to be. So you had negative x squared you had negative x squared minus 3, and I have x squared plus 3. So that's, yes, that's fine. Okay, why am I happy?
This is
because these match. So my final answer is x squared plus 3, x minus 5. Perfect. Okay, I see number 3 has 3 terms. Is there a GCF? No. So, but what's the leading coefficient? It's 1. Paige get a point. So if the leading coefficient is 1, we get to do normal old plain Jane factoring. So I need 2 things that add to give me -3 and multiply to give me -4.
1 and -4.
I know I heard it from 1 and 2. Did I hear it from you too? That's what I thought. 1, 2, and 4. Okay, so it has to be, I think I heard one of you say the wrong sign. So it has to be a -4 and a positive 1, because -4 plus 1 is -3. -4 times 1 is -4. I had a feeling. Okay, and then we almost see mad at number 4 because there are only 2 terms. What's special about the number 81?
It's a divisible by
Yeah,
9.
yeah, -9 and then times 9.
9 goes on.
You can have the point, Angel, but I just wanted to know that 81 is a perfect square. Okay, I get it's divisible by 9, but more specifically, it's a perfect square. 9 squared is 81. So anytime you see a perfect square and there's a minus sign, it ends up being the variable plus whatever it is normally squared and then the variable minus it. So the reason that happens, so it's d plus 9, d minus 9. The reason that happens is because if we were to FOIL it out and check ourselves, we would have d squared for the first term, negative 9d plus 9d, so the outer and inner would cancel out. Positive 9, negative 9 gives you negative 81. So anytime you see a perfect square, I end up getting really excited. So for instance, I'm pretty excited about number 8, which is tomorrow's deal. Okay, if you're trying to get ahead, we're going to do 5 through 8 tomorrow. In fact, I'm trying to get us back on track, so we'll probably do 5 through 8 and 14. You're that on it. That on it. Yeah. Okay, let's look at, we're going back to matrices. We're doing some new notes today. We're on the next page, so I believe it's page 5. Okay, so past 3 days, we've been talking about something called a matrix. It has dimensions. You figure out what size it is. Each spot inside the matrix is called an element. And then what you practiced yesterday was adding, subtracting, and multiplying by a number on the outside, which we call a scalar. And that worked out pretty nice. So when you added, for instance, we zoomed in on number 1, and we pretended that was an addition sign, you genuinely just added who you thought went together. 4 goes with 3, so 4 plus 3. Negative 2 goes with 0, so negative 2 plus 0. And life made sense with adding and subtracting. And life made sense with multiplying by a number on the outside because everybody got multiplied by that number. The only thing that doesn't necessarily make sense with matrices is multiplying, which is what we're talking about today. Multiplying is a little more complicated. We're not just going to do 4 times 3 and just say it's 12 for that top entry. That sounds cool, but that's not how it works. So if you have colors, you might want to have them out. Before we go crazy, the first thing we're going to do is go through all 9 of these problems and write out the dimensions of each matrix. So for instance, number 1 is a 2 by 2 and a 2 by 2. I'm willing to give out points. What's number 2?
2 by 2.
Point for Daniel. Number 3.
2 by 2, 2 by 2.
I'll give it to 3. And then table 4, do you want to handle the next one?
2 by 2.
And number 4.
2 by 2.
Ah! Rows, then columns. Okay, I didn't hear you. Nick can have a point because I've epically confused him. And then table 5, do you want to handle this one?
3 by 2. 2 by
Okay, table 5 gets a point. Table 1, we didn't give you a chance.
2 by 2 and 2 by 2.
Table 2, we're back at you. 1 by
2.
Mm.
1 by 1.
How many rows?
3.
Okay. There are 3 columns. Okay. You can get a point for that. No, Cooper, sorry for earlier. Number 8.
2 by 2, 2 by 2.
You have a point for that. And then Nick, back to y'all's table. Number 9. Thank you, Jax. Okay, and then Ellie, I'll give y'all first dibs at this one. Let me get my words out for you to answer. What is it called when a matrix is like a 3x3 or a 2x2? There was a name for that. It's square. It's called a square matrix. Do you have a point for that? Okay, so a square matrix, which is going to come up. So, but yesterday, if the matrices weren't the same dimensions, you couldn't do any math at all. So, for instance, number 4, you would say we can't do this if this was addition because they're not the same dimensions. That doesn't actually pertain to multiplying. There are different rules of multiplying. When we multiply two matrices, we actually need to check to see if the number of columns of the first matrix matches the number of rows of the second matrix. So if the two inside numbers match, we are able to multiply. But if the two inside numbers do not match, we are not able to multiply. There is one example below that we're not going to be able to do. What is the one example? Number 7, Paige said it first. Number 7 is not going to work because the inside numbers are a 2 and a 1, so it's not going to be possible. We need the inside numbers to match. 2, 2, 2, 2, 2, 2. If the inside numbers do not match, multiplication is not going to happen. What's really cool, though, is while, yes, these have to be the same, the two outside numbers tell you what the product's going to be. So my answer on number 1 is going to be a 2x2. My answer on number 4 is going to be a 2x3. My answer on number 8 is going to be a 2x2. The outside numbers tell you what size matrix your answer should be. So that's the cool part. So let's go to 1, 2, and 3 at the top. It says, determine whether each matrix product is defined. If so, state the dimensions of the product. So what is the answer on number 1? What would the matrix be if we actually multiplied A and B? What size? 2 by what? By Cooper. It's a 2 by 3. The 4's matched, so we can do it, but the resulting matrix would be a 2 by 3. Okay, what am I going to put on number 2? Nick, get a point. The 4 and the 5 don't match, so since the inside numbers do not match, this is not possible to begin with. But if it was possible, our answer would be a 5 by 4. Okay, number 3, what is the resulting matrix? Okay, so you're like, thank God, every group can have a point. You're like, thank God I don't have to do that one, because that's a lot of entries. 8 rows, 10 columns, that's a lot of junk. So the good news is, and I'll let you come get it this time, we're going to do the first 4 by hand to understand how this process works, because yes, there could be a test question, well, probably not a test question, but there could be a standardized test question that actually wants you to show you understand how this process works. So you need to understand how to multiply. But from here on out today, once I get to number 5, and for the rest of what we do with matrices, you're going to be able to use your calculator. So if you need to come get a calculator, come get one now. And if you want to get out colors, now would be a good time to get out colors too, because it's a very colorful day. Okay, so here's why you really want colors. If you want to read how they explain it with letters, you can. I like to do things with colors, as you know. So I'm going to do it with colors. When we multiply a matrix, or two matrices together, we multiply rows by columns. We're going to do the first row with the first column, and that's going to give us our first entry. So we're really going to multiply these two numbers and then add them to these two numbers, and whatever that answer is, that's going to be our first entry. And so for our second spot on that top row, we're still going to do first row, but we're going to do second column. So this plus this is going to give us that second entry. So for that third entry, we're finally on the bottom row. Well, unsurprisingly, we're going to use the bottom row in the first column to get the pink entry. So this plus this gives us the pink. And to get the very last spot in this matrix example, we'll do bottom row, second column. So this plus this will finally give us that bottom one, which may or may not have made sense in color, as we're about to work 4 examples with it. It's really not hard, but it's not as common sensey the way adding and subtraction were. Addition and subtraction just made sense, whereas multiplication you actually have to think about. Okay, so I'm going to leave that up there, but I'm going to handle number 1. So first row, first column, I'm going to do 4 times 3, which is 12, plus 1 times 0, which is 0. So my first entry is 12 plus 0, which is 12. Now I'm going to write it out and then skip to the answer. If you're a genius and you just want to skip straight to the answer, no one's mad at that. So again, I did 4 times 3, I got 12, plus 1 times 0, which is 0, which is how my very first top entry is a 12. Now I'm going to do my first row and my second column. So I've got 4 times 0, which is 0, plus 1 times 3, which is 3. So 0 plus 3, which is 3. Okay, I've still got 2 more entries to go. Bottom row, first column. So negative 2 times 3 gives me negative 6 plus 0. So I just get negative 6. And then last but not least, bottom row, last column. Negative 2 times 0 is 0. Negative 2 times 0 is 0. 3 times 3 is 9. So I get 9. So when I multiply this matrix times this matrix, my answer is the matrix 12, 3, negative 6, 9. Are there any questions about this? Okay, I'm going to do it again, and then I'm going to let you practice on the next 2 by 2. Let's see. So on this one, I'm going to do negative 1 times 3. I get negative 3. Plus 0 times negative 1. That's 0. So my very top entry is just negative 3. Top row, second column, negative 1 times 2 is negative 2, plus 0, I'm going to get negative 2. Green. So I've got my top row done. I now need to use my second row. 3, 7 times 3, negative 1. 3 times 3 is 9. 7 times negative 1 is negative 7. 9 minus 7, so 2 is my next entry. And then last but not least, still that bottom row, but now with that second column, 3 times 2 is 6, plus 7 times 4 is 28. 6 plus 28 is 34. So when I multiply those 2 matrices together, I should get negative 3, negative 2, 2, 34. Okay, did anyone not get one of those entries? They want me to go back over it? I do not mind. Okay, well then I'm going to give you a chance. Here's your shot with my remote go. Here's your shot. Number 3 is yours. Why don't you try it? First one with the right answer will get their group of point.
3
Whoa, Daniel. Yes, dear. Sure. Mm-hmm. And you're not showing anything, are you? No, I wouldn't either. Okay, we'll give everyone else a chance to be normal and use your brain before we show all the answers and all the things. I mean, the answers are in the screen before we talk about it. Okay, so I did 3 times 3, which is 9. 9 minus 2, which is positive 7. If you want to stop showing it out and want to start doing math in your head, that's fine. Again, 3 times 3 is 9. Minus 2, I get positive 7. If you want to write it, you can. Honestly, I just eventually start putting the answer. So that was our first row, first column, gave us that 7. Now, first row, second column, 3 times negative 1 is negative 3. Negative 1 times 4, you get negative 4. Negative 3 minus 4 is negative 7. Now my first row is completely done. I'm moving on to my second row. Second row, first column, 3 times 2 is 6. Plus 4 times 2 is 8. 6 plus 8 is 14. And then last but not least, last row, last column, negative 2. 2 times negative 1 is negative 2. 4 times 4 is 16. Negative 2 plus 16 ends up being positive 14. So again, if you're starting to think these numbers through in your head, you do not have to show work out at all. The work does help me if you make a sign error, but honestly, I get that that's tedious. So if you just want to go straight to I did math in my head, that's fine. Okay, let's handle number 4. We'll do it sort of together-ish. We'll do it one thing at a time. Okay, yes, dear. What should our answer be on number 4? What's the resulting matrix? The dimensions. Thank you. Get a point. So our matrix is a little bigger than our other examples. I need to know the first row. Does anyone know the numbers in the first row? Like, you already multiplied it out. What did you get? Then what? Then what? You have a point for that. Okay, so how is he doing this? Negative 3 times 4 is negative 12. Minus 3, negative 15. Negative 3 times 0 is 0. Plus 1, positive 1. Negative 3 times 2 is positive 6. Plus 1, get positive 7. Woohoo. Does anyone other than Daniel know the second row? Nobody? This is alarming. Yes, dear. 26. Negative 2. Negative 13? And negative 12. Okay, you can have a point. Okay, how is he getting this? He is not using all the colors. He's just doing 5 times 4, so he's on that bottom row, so it's bottom row, first column gives him that first entry. So 20 plus 6, he got 26. Bottom row, second column, 0 minus 2, he got negative 2. And again, last but not least, bottom row, third column, negative 10 minus 2, he got negative 12. Are there any questions about number 4? Matrix multiplication can be tedious, and there is potential for sign errors. There is a way to alleviate this, and for Paige to catch herself by checking herself with her calculator, which we're going to go over now. What's going to happen, though, is once I show Paige how to do this in the calculator, she's going to forget the process, which is potentially bad, because I'm not saying on the test you're not going to get your calculator, because you are, but there's potential of you're going to make a typo, because we're not all geniuses. I made a typo yesterday. We are not all geniuses all the time. So you're going to make a typo and not have any work to show. Or the ACT, again, they might ask about one specific entry and want you to do one specific line, and you kind of have to understand the process in order to answer their question. Because, no offense, they understand everybody can operate a calculator. Okay, but from here on out, today, I'm going to show you how to do it in the calculator. So if you press your calculator on, there is a button that says matrix and is in blue. It is right here. It says matrix. How do I get to that blue button? Press second. So second, matrix. We want to type stuff in, so we need to scroll over to edit. Now, you have lots of options. Look, there are at least 7 different matrices here, and there's a down arrow. So I bet we could do the whole alphabet, basically, of matrices. But we're lazy, so we'll probably just type in A and B. But we do not have to be lazy. You can store them in all of them. Okay, so I'm going to edit A, so I'm going to press enter. I pressed enter. On number 5, my first matrix is a 3 by 2. So I need to tell it I want a 3, enter, 2, enter. And now I can type in my entries exactly like I see on my paper. It should be 3, negative 2, 0, 4, negative 5, 1. I press the number and I press enter each time, and it gets me to the next entry. Is there anyone here who is stuck? Okay, well then let me warn you. Well, that part seems pretty easy, and hey, now my matrix here matches what's on my calculator screen, so hey, this is about to do math for me. Awesome. There is potential for errors because when you press the negative sign for minus 5, make sure you're pressing the tiny one. Don't press the big old minus sign. It's going to tell you that it can't do it. And you're going to think it's a not possible one, and it's not. It's a human error. You can't. It's on you. It's not on it. Okay, so we've typed in matrix A, but we need to type in another matrix for the other matrix we want to multiply. So to get out of this, press second, quit. Quit's in blue. It's right by its mode. So now we're back to our home screen. If we'll press second matrix again, we can go back and edit, but it would be silly of us to edit A. We just typed in stuff in A. We want to go to a new guy like B. Our second matrix is a 2 by 2, so I need a 2 by 2. My entries are 1, 2, 2, 1, 1, 2, 2, 1. And now I have matrix A and matrix B storing the 2 matrices I need for my problem. Which sounds awesome. Okay, is there anyone stuck here? We're going to second quit and go back to our home screen. We now need to do math with those matrices. The first 2 times we were pressing edit because we needed to type stuff in. Now we're going to press second matrix, but we're actually going to do math with it. So second matrix, I need A, so press enter on A, enter. Then A pops up on my screen. If you press enter again, it'll show you all the entries of A, but we don't need that. We want to multiply A and B, so I need to get B as well. So second matrix B, and now I have A, B on the screen, and your calculator's smart and understands that that's multiplication. You don't put a sign in between, it's multiplication. So if you press enter, it does it for you, and lo and behold, there is the answer. So number 5's answer is -1,484, -3, -9. Cooper didn't have to think. He didn't really have to do anything but operate a calculator. So -1,484, -3, -9. Which is great, but then now there's the potential of what if Daniel makes a sign error? Maybe Daniel should check himself by hand as well to make sure nothing went wrong. He's not going to. He's going to assume he be genius. And then the moment he not be genius, it's going to hurt. Because all I'm going to see is this. And bless his heart, he just copied wrong, and I'm not going to know it. Okay, are there any questions about this? Let's go type in number 9. So I'm going to go second matrix. I'm going to edit. I'm not going to pick A or B because you don't have to. We can use different letters. I'm going to use E and F. I want to edit E. On number 9, it is a 3 by 3. So I'm going to make mine a 3 by 3. It's 2, 0, -3, 1, 4, -2, -1, 3. 1, and I check. Yep, what I have typed on matches the one on the screen, so I'm good. I've typed this one in, so I'm going to second quit, and I got to go edit letter F so I can type the second one in. So second quit, second matrix, I'm going to edit letter F. F is a 3 by 2. Its entries are 2, -2, 3, 1, -2, 4. So if I second quit it, I need it to do E times F, so second matrix, I want E, second matrix, I want F, and lo and behold, it did the math for me. The answer to number 9 is 10, -16, 18, -6, 5, 9. Okay, I totally get how this is so much faster and life just got so much easier. There is at least one thing Daniel should check though. What is the one thing he ought to check before he assumes his calculator is genius? Well, he should check that all the time, but what did we decide the answer had to be? So if your answer is not a 3 by 2, because that's what we decided it had to be, you've done something wrong. So at least check, I was supposed to get a 3 by 2, I did get a 3 by 2, that seems pretty good then. Okay, the ones we skipped, 6 and 8 are yours. Don't even bother to type in 7, your calculator's going to tell you it can't do it, because it's not possible. Other than that, I'm done bothering you today. I'm going to look through the checkpoints that were turned in, but seriously, we're not worrying about the checkpoints until tomorrow. Make sure you bring your workbook tomorrow. Is there anyone stuck on a calculator issue? Oh, and first period asked me a really good question you hadn't asked. Someone have a good question about the calculator buttons they want to ask me now? It would be a lazy man question, but still a good one. No, this is as easy as it gets. Can I go back and do addition and multiply by scalar, or, I don't know, subtraction with these? And absolutely. So if your problem said to do 3 times what we typed in as A, seriously, 3, second matrix, A, your calculator can do all the things you had to do yesterday for you. Now, it can't solve for a variable, so when you're typing in stuff, don't put an X, Y, and Z. It's not that good. Well, you don't know how to tell it to be that good. It is that good. But yeah, so everything we've done up to this point, you can now do in your calculator. And I won't know until you make a mistake because you didn't put any work on your paper. So this sounds like one test where I'm not expecting a lot of work, and that's okay.